lecture. My name is Sonain Jamil 16T16 registration number. Today our topic is Z transform. We will see the definition of Z transform and some examples today. So what is Z transform? Z transform is important tool in describing and analyzing digital system. It tells us whether the system is stable or unstable. We can find the stability of the system by using Z transform because it can give us poles and zeros, and then we plot PZ plot. From there we calculate whether the system is stable or unstable. So the definition of Z transform is, if we have x of n in time domain and we want to convert that x of n in Z domain, we will follow this formula. Summation from n is equal to 0 to infinity x of n multiplied by z power minus n. We can write it as this one. So let's have some examples. If we are given this signal in time domain, that is x of n is equal to 125701 and 0 index is at 1. So if we apply the Z transform on this formula, this is x of 0 multiplied by z power 0, which will come out to be 1. Then this one, x of 1 multiplied by z power minus 1. Similarly the other ones. So the ROC is entire C plane except C is equal to 0, because if we substitute 0, Z is equal to 0, the system will become unstable and it will approach to infinity. So the region of convergence is entire Z plane. So the question arises here is, what is region of convergence? Region of convergence is the region or area where the system gives us a finite response. For that region, system gives us finite response. It doesn't approaches to infinity, or it doesn't become unstable. So the second example here is, this is non-causal system. The previous was causal and this is non-causal system. As you can see that the 0 index is between the all the sequences. So if we apply Z transform on this, what will come out to be? If we substitute the value 0, then the system becomes unstable, approaches to infinity, and if we also substitute Z is equal to infinity in the equation, the system will also become unstable and it will approach to infinity. Here is the another example. If we have impulse signal and we want to find these Z transform of impulse signal, it will come out to be 1 because impulse is 1 at 0 and all other values of n it will be 0. So if we take the summation of all the things, it will come out to be 1 because there is only 1 at 0 and all others are 0. So here ROC will be the entire Z plane. Here is the another example. In this example, there is a slightly difference, which is that impulse is shifted by a term k, and or this impulse is just shifted to k sample, k index. So if we take the Z transform of this signal, it will come out to be the magnitude x of k into c power minus k. So x of k will be 1 and it will come out to be z power minus k. So here ROC is entire C plane except z is equal to 0, because if we substitute z is equal to 0, this is C transform becomes infinity. Here is the another example. In the previous we have a forward shift, and in this we have a reverse shift. We are shifting our signal to the past or left side. So the same phenomena will happen, and in this case Z transform would be zk and ROC will be entire Z plane except z is equal to infinity. If we substitute value of z infinity, this Z transform of x of n would become undefined. So that's it for today's lecture. In the next lecture we will continue Z transform. So thanks very much for watching.